I built this solar station 10 years ago, and it is designed to heat this house in winter and heat the water of this pool in summer. I bought materials for its construction for $11 per square meter of the solar heaters, and videos on my YouTube channel show how I built them. It is about 10 times cheaper than the traditional solar collectors, and it is several dozen times cheaper than its relatives. These expensive solar concentrators should constantly turn their mirrors according to the movement of the sun across the sky, and now I am starting to show how they do it during a day, and the time is shown here. We know that these expensive solar concentrators are the basis of large solar power plants, and for example, the construction cost of this power plant is $2 billion, and this is its satellite photo. We can see that the rows of its concentrators are located along this south-north line, and these photos of other solar power plants show that their solar concentrators also have a similar south-north location. But now I will show a satellite photo of this solar station, and we see that the rows of my solar heaters are perpendicular to this south-north line, and this is the main difference from those expensive solar concentrators. This location along this east-west line allows the rejection of those mirror turns from morning to evening, and now I will show photos of one day but at different points in time, which is shown here. We see that this spot of solar radiation from my mirrors is located exactly inside the absorber during the whole day. Here we can see that the mirrors were motionless, and these shadows show us that the sun is moving. This day was near the spring solar equinox, and the spot will be exactly inside the absorber also near the autumn equinox in September. But the closer to the solstices, the spot gets inside the absorber less accurately, and now we see the movement of the spot on the summer solstice in June. Now I will show how the spot moves on the winter solstice in December. Interestingly, in winter the spot comes from above, but in summer it came from below. And the spot goes up in winter, but in summer it went down. You may notice that our cheap solar heater has a high absorber. At the same time, this expensive solar concentrator has a thin absorber, and its mirrors are expensive due to the fact that they must be very precise, because its spot must be a very thin line. But our equipment does not have to be precise, and therefore it has the right to be made from cheap materials using primitive technologies which do not require large investments. In addition, our solar heater does not have these expensive structures to hold the high-precision mirrors, mechanisms for their constant turning, and expensive fixation to the ground. But you might notice this difference between the vertical angles of the mirrors in summer and winter, which is a consequence of the fact that the winter sun is located near the horizon, but the summer sun is noticeably higher. That is why my next video will show how I solved this problem on my solar station.